Hello everyone. We have another pre-recorded recitation today going over Json Web Tokens. Got some TL training during lunch, so I'm just going to run through this real quick because I'm going to be working off of our cookie-based project from yesterday with the React app already set up. So really all we need to do is tear out the cookie bits and replace them with JWT bits. So first thing we want to do with this project is we no longer need our connect session next and express session packages, so I can go ahead and do a yarn remove express session and connect session next. If you're starting, with a greenfield project here, you don't really need to do this step, but for any of you following along, it doesn't matter that they're still in there if we're not using them. It's not going to cause any harm other than just weighing down our node modules folder. So if you're not using dependencies, you might as well take them out. And then we need to add the Json Web Token dependency so that we can use our Json Web Tokens. So now that that's good, I'm going to get our server up and running, and it is immediately going to crash on me because we don't have express session or any of that installed. So I'm going to go into my index.js and I am going to get rid of all of my session stuff. No session, no next session store. Don't need the database connection anymore. I can get rid of my big ol' session config. I don't need to do any of the complicated CORS stuff. If we're using Json Web Tokens, we just need to enable CORS if we're making requests from our front end and it's on a different domain. You can, if you want to, still restrict the origin to your specific domain or a certain subset of domains. That's totally allowed. But we don't need this credentials thing because we're not doing cookies anymore. And just to keep it simple, I'm going to get rid of that. Don't need our session stuff. All right. There we go. So our server's up and running, but our authorization is not working. And I want to be clear, our authentication is totally fine. If we go into our auth router, right, our register still works exactly the same. All we're doing is we're storing this user in our database. We're performing that storage there, and then in login, we're checking the login information versus that stored information, and that still works. What needs to change is how we handle the authorization. Inside of the login, we're setting this session here, which is going to end up giving the user a cookie that is going to have an ID that we reference, or the middleware we installed references, in order to tell if this user session is currently authenticated based on them having this user information here. And we're not doing that. Instead, we're going to generate a Json Web Token. And that is going to be our system for authentication. And we're going to do that using the library that we just installed, the Json Web Token. We can do this directly in line here if we wanted to, but chances are we might want to do this in another place. I mentioned yesterday that one of the only way really to tell if we have a valid session or not is to make a request to an endpoint and see if it 403s or not. And also we have this issue with logout. I forgot to do the logout yesterday. I apologize about it, but it's very easy. To log someone out, all we do is we destroy their session on our server. But when we use Json Web Tokens, we don't have that ability because we're storing all the information client side. This is client side auth. We're giving them a token that is valid until a given time. It is valid by the laws of mathematics. And we cannot invalidate that without either changing our secret, which would prevent us from appropriately decrypting the signed part of the token and essentially invalidating all of our tokens, which we generally don't want to do, or by essentially recreating a session where we check the token to see if for some reason we've blacklisted it, like the user wanted to log out early, or the user changed their password and we're disabling all of their existing tokens, things like that. So what was my point here? Um, I don't remember where I was going with that. Oh, so we have this kind of twin problem of terminating tokens early is difficult, but then also determining if a user has a valid session can only really be done by verifying that session against the server. And one way to kind of meld those two together is to give our tokens short lifetimes. With a cookie, we can set the max age to be like, like months, and it doesn't really matter, although some browsers will restrict the lifetime of our cookies. But with a token, we can give it a relatively short lifetime, like a day, and just whenever the user logs into the website, or not logs in, but loads the website rather, we'll make a special request to check and see if they're auth to an endpoint called refresh. And what that will do is it will check and see if the user has a valid token, and if it is, it'll give them a new token with an updated lifetime so that they can be logged in for the next 24 or however many hours. But if they don't have a valid token, then that endpoint will throw a 401 error, and then the front end will be able to know that the user does not have a valid session and can redirect them to login. So kind of two birds, one stone there. It doesn't completely solve our de-authentication system, but if we keep those lifetime shorts, it's much easier to feel a bit safer with the prospect of just letting that token expire in a little bit. And it also reduces the amount of storage we would need to do on our side in terms of invalidating tokens before their expiry date. So, a little bit of a tangent there, but we're going to be ripping out our session stuff, and we're going to be generating a token. And we're going to want to do this in multiple places, so we're going to want to write our own function in order to perform this generation. And so let's do that. Let's do that. So let's write our function here. And if we write this function, we can declare this anywhere we want to, right? Function definitions are hoisted. We can use them before they're declared in the file. I still prefer to write it at the top. So I'm just going to rip off what Luis did. And we're going to have a generate token function. And it's going to take in a user object. And we're going to create a token. Now, the token is going to have a couple parts to it. The main one that we're concerned with, that we actively have to do something about, is the payload. And what this is it is just a JSON object. The whole point of these JSON Web Tokens is that it's just base 64 encoded. So you know how we have decimal numbers 1 to 10, and we have our alphabet, which is base however many letters there are in the alphabet. We also have hexadecimal numbers, which are base 16, which we're familiar with from setting colors in CSS. Right, those colors are in hexadecimal format. The numbers go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 is A, 11 is B, so on and so forth. And so we also have base 64, which is kind of a form of compression, essentially, because we can represent a lot more information within a single character. But if we were to unbase 64 encode these, we would just see stringified JSON objects. So we can store whatever information we want in here. And the advantage is that our client is storing this information. When we did sessions with cookies, we were storing that information on our end. The cookie just contained some unique ID that helped us identify their session and then look up in our database what information we had decided to store. So we need enough memory or disk space in order to have access to that. And also, if we have multiple servers that the user can potentially be visiting, we need to share that information between the servers. With JSON Web Tokens, we are able to tell via the divine truth of mathematics whether or not that token is valid without any of that shared information. And we can put as much junk in there as we want and not have to worry about running out of memory if we have millions of users, because the users are storing that. Now, I don't recommend packing this full of stuff because it's going to waste bandwidth, because this is going to be sent on practically every request, and also this information might become invalidated. We don't want to store like all the user information in here because some of that may change in between requests. So usually we want to store, like the user ID and the username and some things that are guaranteed to be static, but we also want to know so we can identify the user making the request. Here we're going to just toss in our user object that we're getting from this argument, and we're going to give it the username. We could also put in the user ID here if we wanted to. I would not recommend putting the user password in here, because don't do that. Don't give people their hash passwords. That's a bad thing to do. And then with our JSON Web Token, we also have to specify some options. This allows us to determine when this token is going to expire. And we can keep that expiry date relatively short, much shorter than we generally would with cookies, because usually we will have the user refresh this token at various points in time in order to remain auth. Now we're going to need to require our JSON Web Token library. So require, typing is hard, require JSON Web Token. And this is going to perform the complicated operation of representing the JSON Web Token in that base64 encoded string that contains 3 parts. Contains information about the token, the algorithm used to generate it and such. Our payload, which is going to be the information that we want to store along with that token. And then also the signed bit. So at the end of our token, we essentially pass the previous parts of the token into a cryptographically secure hashing algorithm, like our password. It's a one-way deal, right, with our password hashing algorithm. Only if you have the correct input, which is the right password, but also the right secret, do you get the same result. And that's how we sign these tokens with a hashing algorithm. It's one way. So only if the user gives us back the identical contents of this token that we sent them, and we use the same secret that we supplied when we generated the token, will we get that same signature back. So this prevents users from tampering with any part of the token. And to do that, we need a secret. Louise had it set up so that he defined the secret in another file, and that's probably a good idea. I'm going to be a little bit lazy here, and I'm just going to do it in line here. We're going to do this with the jwt.sign function from our package. The first argument is going to be our payload. The second argument needs to be the secret, which we can get in production from an environment variable, right? Secrets shouldn't live in source code. Probably want them in environment variables. So we'll call this JWT secret. And if that's not defined, if we're in development, we'll just use some gobbledygook there. And then we also want to specify our options, which is for us going to be the expiry date of that token. So now we have a function that generates a token. There's a decent chance that we'd want to put this definition in another file so that we could access it. It's just going to be local to this this router, so I'm going to leave it in here for now. And now when we log in, we're going to want to generate that token. Generate token with that function we just defined. We're going to give it the user object that we got out of our database. And now I'm going to pass this along with the response body. And we can put this under any key that we want. I prefer token. Some of the old projects put it under payload. I think it's just simpler to leave it at token and have it be that. But you might encounter some front-end people in Build Week that are a little bit confused about that. You know, just make sure they're console logging the response, which they should always be doing if they're uncertain of what the format is, or write good documentation. So now we're appropriately generating and giving this token back to the user. The next step of our authorization is going to be able to recognize that this token is valid. So to do this, we're going to need to go into our restricted middleware. And instead of checking to see that they have a valid session, we're going to check to see that they have a valid token along with their request. So the way we're going to do this is we're going to have to import our JSON Web Token library again, because this is going to give us the ability to decrypt those tokens. I'm sorry, not decrypt. We're not encrypting our tokens. This is going to give us the ability to verify the token, that when we perform that hash again, that it is going to be the same value that the token bears. So in order to do this, we can cut all of this out here, and we're going to need to grab the token from the user. They can send this token however we decide here. Generally, we want to include the token within the headers, because the idea is that this token is not relevant to the direct functionality of that endpoint, so we don't want it inside of the request body. They could send it in there, but also we don't want to send bodies with get requests and delete requests. No. So generally our authentication information goes in the headers. We could also, if we really want to, we could send this token inside of a cookie. And that's one way to securely store JSON Web Tokens, is inside of cookies. And we can handle that the same way we would be handling cookies, except the payload of the cookie isn't going to be a session ID. It's going to be a token we want to access directly, which is kind of neat. But for now, we're going to get it out of the headers, which Express is kind enough to supply us with as a JavaScript object instead of rec.headers. And we'll call it authorization for consistency. You can call this whatever you want it to be, as long as it doesn't conflict with some header that, you know, the browser and server both respect in some other functionality. First step, we want to check and see if the token exists. If it doesn't, then they're not making it. They're not making it. So we can send them an error message right away. Res.status 400, because the user sent a request that was in some way malformed, and we can give them a message saying no authorization token provided. Okay. If the token does exist, we need to verify that it hasn't been tampered with, but also that it hasn't expired yet, because we've encoded the expiry date in there, and we need to check both of those things. Luckily, the JSON Web Token library does that for us. So we have a function, JSON Web Token verify, and we have to give it our token, and then we also have to give it the secret, which this is probably why we want to store our secret information in another file. I'm going to be lazy here, copy and paste this. And then we also want to give it a callback. So JavaScript used to exist in this system of callbacks before promises were really standardized and widely used. And so whenever we had a function that wanted to perform some action when it was done running asynchronously, we'd provide a callback. And sometimes you'd have to provide callbacks to those callbacks, and you'd have to provide callbacks to those callbacks to those callbacks. And this is what we refer to as callback hell. This isn't too bad because we just have a single callback, but this is how it all used to work. So this function is going to take two arguments. It's going to take an error and then the decoded token. So instead of doing our then and catch, we have to check and see if the JSON Web Token verify function has produced an error while trying to decode this token. And if it has, then we need to handle that appropriately inside of our callback. But if it hasn't, it'll give us the decoded token, and then we can authorize the user. This is our replacement, for then and catch, is this manual error handling style. So if an error exists, then we want to deny the user access, which we can do by just sending them a status. This is going to be 401 because they're not authorized. We'll just say token not valid. We could specify whether or not, based on the contents of this error, the token had expired or if the token had been tampered with. honestly just find it, tell them it's not valid. But if it is valid, then we want to pass them to the next piece of middleware, right? The whole point of this is we're conditionally performing this next operation. If some things are in place and the user is who they say they are, then we want to continue on to our endpoint. But if they're not, we want to send these status messages. So we do this next. We also want to recover some of the nice functionality that the sessions and cookies did, which is that in our request object, we magically had this information about our user. And lucky for us, when we decode the JSON Web Token, it's going to have whatever contents we put inside of there. So we can attach that to the request body ourselves. So instead of modifying the, not the request body, the request object. So instead of modifying the request object on authentication, we modify the request object when we verify the authentication. So I'm going to set request.user to be the decoded token. And we could set this to be some part of the decoded token. I know this only contains the username and the ID, and that's just fine. We might have some other information that we wouldn't want to store in here or we want to store somewhere else. Absolutely allowed to do that. So that is our process for getting tokens to work. So let's go ahead and test this in Insomnia. I am going to log in, and there we go. So now we get our token. And we can see it has these three parts to it, each of them separated by a period. And I know Luis showed this during lecture, but I think it's pretty cool. So let's go ahead and look at the contents of this token. Because again, it's just base64 encoded strings. And so if I drop my token into here, we can see that we have this header, this first part, which says things about the way that this token was encoded. And then we have our payload, which is going to be the data that we supplied with the user. And we have our ID in here. I don't know why the username's not showing up. Did I? Oh, because it should be user.username. There we go. Caught a bug. All right, so let's do this. We instantly get another token, and we can see it's actually slightly longer. It's because it has more information in it, right? We don't get to store this information for free. It's going to increase the length of our token, and there we go. Now we have the username and the ID. And then we also have this secret, right, which we generate using a hashing function. When we're hashing our passwords, this would be bcrypt. This one is apparently HMAC SHA-256, so that's our hashing algorithm, and we have to give it in this specific format: the base64 encoded header plus a period plus the base64 encoded payload. So basically, the first part of this token, and then the secret, which is not included in the token that we send to the user. Only we have that on the server side. And if we supply all these bits of information to this algorithm, it will always produce the same result. So we know that we haven't tampered with any of this. And that's how we can be certain that we're storing this information client side and everything is cool. Now, there's also a thing called encrypted JSON Web Tokens. These are just signed JSON Web Tokens. The user can unencode this payload and view its contents at any point in time. And that might actually be helpful. When you do your build weeks, if you want your front end to have any information upon login, like the user ID or the username, I would honestly just recommend including that in the response body. They could decode the token and grab this out of here, but that's something that they haven't seen before, and unless you have tons of extra time, probably better to focus on your CRUD stuff working than teaching them about the contents of JSON Web Tokens, because they'll learn it in a month. But we could avoid sending duplicated information by just having them decode that token. We could also encrypt this with not a one-way hashing algorithm, but an algorithm that given a secret will perform the encryption, and then given a secret will undo the encryption. So this is how we could store sensitive information client side. I don't have any strong opinions about that. I'm sure there's a billion Medium articles about there saying why you absolutely should and shouldn't do that. But yeah, just wanted to let you know about that. Okay, so now we have our token ready to go, and we can actually verify it right here. I'm gonna pass that in right there. Yeah, see, now we see that our token is valid. And if I try to modify any of this, well, that should have invalidated it. Yeah, see how this secret is changing as I type in here? Or not secret, but signature. That's because the contents of this change. So when we provide it to the hash here, it is going to give us a different result. So we would be able to verify that has indeed changed. Now, it's doing this on the fly because I gave it the correct signature in order to perform the hashing with. If the user were to modify this part and then send the token back, they wouldn't be able to update this part to match. And so we would see that providing it this value gives us this instead of what we originally had. So that's how that rejection would happen. Okay, now let's test and see that the authorization works. So here is my token. I'm going to copy it. And now when I do get, instead of doing anything with cookies, I'm going to include a header. And it's not going to be the username and password like we had previously. It is going to be authorization. Authorization. And the value is going to be my header. I'm sorry. It's going to be my token. When I send the GET request, we see that it works. It returns all the users. I can try changing any part of this, and that's going to end up making my token not valid. I could also wait until the token expires, and it would also reject it in the same manner. We could set the lifetime of our tokens to be like 1 second if we really wanted to test that behavior, but this is good enough for me for now. And let's go ahead, let's write that refresh endpoint real fast. Because another thing we can do there is to have the user be able to, get their user information based on them having a valid session. So I'm going to go down to the bottom here. I will write it at the top, just to make it a little bit easier. So I'm going to do router.get and call this /refresh. We're going to get our rec and our res. And what we're going to do here is we're just going to give this user a new token. And we're going to be able to do this because the old token is going to have the information to verify that user. So we can just restrict this endpoint. Aha, middleware is super useful. So let's go ahead and require restrict require. That's going to be /restrict.js. And there we go. Now this endpoint will be restricted to users that have a valid token. We can go ahead and get the user based on their username or their ID. So I'm going to just steal this bit. And we can get their username out of that rec.user, right? Out of the token. Because with the restricted middleware, we've now set in the request object the value of the user to be the user object stored inside of the token, and we're going to be able to get their username. Then we're going to get this user object, and I could just plop the old information into the new token, but we might as well check and make sure none of that our user information is changed. And we can go ahead and generate a new token. And this is going to generate a new token with an expiry time 1 day from now. And the user is also going to know that they're logged in because we're going to tell them that. Give them a 200 and send them back the token as a response. They don't really need a message saying that they've logged in. This 200 is enough. But in the case that they haven't given us a valid token, well then the restrict middleware is going to take care of that. So let's try this now. Let's go hit up /auth/refresh. And there we go. There's our new token with our increased expiry time. And we're able to know that we do indeed have a valid token all in one fell swoop. And notice that our old token is still valid. We can have multiple tokens out per user. We can have as many, honestly, as they want, because each token is going to be valid until that expiry time hits. While we're at this, why don't we go and update our React application? This should be very familiar at this point. Go into Client. We are going to hit up the source, and in our login component, what we would do is we wouldn't have to worry about any of our CORS things, so I do not need to say with credentials. We're just going to perform our login. And then on success, I would want to store that token. Now, you're going to find some people that have opinions about storing tokens in local storage. It's fine for now. It's fine as a first pass. If you want to make it more secure later, you can do that. So I'm just going to store my token in local storage, put it under token, and I'm going to use res.data.token because that's where the token lives in our response. And there we go. That should be it for logging in. And now, when getting the users, again, we don't need this with credentials. We would need to send along with our request the token. So normally we would do this with our Axios with auth function, which uses axios.create to add in some information to our headers. We can also do this manually if we wanted to. It's better not to repeat ourselves, but I want you to know that there's no magic in axios.create. It's just setting this settings object. Previously, we were using the settings object to set with credentials to be true. But inside of here, we can also set our headers. And so I can set the authorization header to be local storage.getItem, and then set that to go ahead and get our token. And now we can also use this to write our restricted endpoints exactly as we would. So that should do it for getting our React app working. We've seen that many times before. Tokens on the server side, we need to create a token when the user logs in, potentially when they sign up as well. We just haven't been doing that here. And then verify that token in our middleware. And that's about it. So please reply to this video thread in Slack with any questions that you have, and I'll be sure to answer them when I have time. And I'll also see you later tonight when we talk about testing. Yay, testing! Woo! Get excited. I like testing. We're going to have a good time. Okay. Thank you so much, and I will see you later.